Welcome everyone. I'm Norman Wahlberger, and in today's lecture we're going to introduce some wider aspects of measurement. This is a rather important thing for young people to connect the abstract arithmetic that they're learning to real life situations, to the idea of quantifying aspects of the world around them. So in our world there are lots of so-called relative notions. Bigger, smaller. It's a description of the relation between two things. Hotter, colder. Taller, shorter. Heavier, lighter. Nicer, meaner. More, less. Lighter, darker. This lighter in the sense of light, while this lighter in the sense of weight. Alright, there are quite a few more. So the idea is that what we want to do is we want to look at some of these notions and we're going to try to quantify them. That means we're going to try to attach numbers to these qualities to be able to distinguish between different ranges more carefully. So we've seen this already in the previous video when we talked about time in the context of the age of a person or the lifespan of a human being. And we introduced the idea of a scale, something like this, where we can plot various years and then position someone on this scale representing how old they are. So if you're 20 years old, you would be represented by that position there. Well, if you're 43 years old, you'd be represented by a position somewhere there, and so on. So this allows us to talk more precisely about things. Instead of saying, well, someone's young, or they're middle-aged, or they're old, we can say more precisely, well, they're 9 years old, or they're 42 years old, or they're 78 years old, and so on. So we want to do that now, not just for time and age, but for some of these other relations. We want to introduce the idea of quantifying things. Now, it's not always possible. For example, the distinction between nicer and meaner is very hard to quantify. You might try, but probably your system of quantifying that will be different from the person next to you. So we're interested in having systems where everybody can agree on the scale that we're introducing. On this slide, I've listed some common measurements and the units that they are measured in. So these are quantities that are accessible to quantification. We've already talked about time, and we saw that there were quite a few different units that we could use to describe time. We had the day, the month, the year, and we haven't yet talked about the second, the minute, or the hour, but they will be familiar to you also. So which of these units we use depends very much on what we're measuring. If we're measuring the amount of time it takes for the Earth to go around the Sun, then we're going to measure in days, months, or years, not in seconds or minutes. If we're measuring how long it takes to run 100 meters, then we're going to talk about seconds, not months or years. So that's a general principle that applies to these other things too. Typically we have a number of different units, and the choice of unit is determined by what exactly we're measuring. So let me introduce 5 other quantities that are very common, that are measurement kind of quantities that we can assign numbers to. The first and probably the simplest one is length or distance. And then weight, area, volume, and temperature. Now, when you learn a little bit more science, you find out that there are quite a few other things that we can measure, but these are kind of primary ones that are particularly important for children in the years K to 6. So let's have a look at them. The first one, length and distance. Now there's the natural question of, well, what kind of units are we going to measure these things in? And since this is such a common and important type of measurement, there is a wide variety of different units available. Some of them, and only a few of them, are the foot, the yard, the mile, and the meter. I've underlined the meter here in green because this is a metrical system unit, while these ones here are so-called imperial system, and we'll talk about the difference in a little while. There are many others. For example, there's an inch, and there's a centimeter, and there's a kilometer, and there's leagues, and chains, and many other things. Okay, when it comes to weight, we're talking about how heavy something is, how hard it is to pick it up. And there we generally measure things in pounds, ounces, or tons in the imperial system, and grams or kilograms in the metric system. The notion of area, talking about a two-dimensional region, the measurement of that is a sort of a two-dimensional version of measurement of length or distance. So we talk about square feet, or square miles, or square meters. And there's a few other ones that are introduced, for example, an acre. In terms of volume, we're talking often about a liquid, how much room a liquid takes. For example, a bottle of milk, or a gallon of gasoline, or maybe the amount of water in a bathtub or a swimming pool. Okay, that's a volume question. And again, the units that we choose there, well, there's pints, there's quarts in the imperial system, and in the metric system, the liter. A sort of a different kind of quantity that's also quite important for young people is temperature, how hot and cold it is. So instead of saying, well, it's kind of hot today, or it's cold today, or it's kind of room temperature, we can quantify that by creating a scale. And there are two important scales used around the world today: the degrees Fahrenheit and degrees Celsius. Celsius usually more associated with the metric system, perhaps. All right, so there's a lot to learn here. We have to appreciate these various quantities. We have to become familiar with the scales. We have to learn about the units. And we have to be able to have some appreciation of the relationship between the units. What's the relationship between a day and a month? Between a month and a year? Between a foot and a yard? Or maybe between a yard and a mile, or a mile and a meter? And so on and so forth. So there's quite a lot of learning that has to be done for young people in this general area. So this is just an introduction. This is just sort of laying out a broad direction. Okay, so eventually in the years K to 6, the child should learn what all these words mean, and they should end up having a pretty good sense of the physical meaning of these various quantities, and have some experience in actually measuring them. All right, so today we're going to stick with the first one. We'll talk about length and distance. As we saw in our previous slide, there are two main systems of measurement in the world today. They are the metric system and the imperial system. And which one you use depends almost entirely on which country you belong. So most countries in the world today use the metric system, but there are a few that still use the imperial system, primarily the United States. The imperial system, which uses units like foot, mile, pound, ounce, pint, acre, gallon, and many others, is British in origin. And today it's still somewhat used in Britain, although Britain has moved officially to the metrical system. It's also somewhat used in Canada, although again Canada is also in the metrical system. The origins are rather personal. So a foot, which is a unit of length around this big, was probably the size of a British monarch's boot. And so it has its origin in human usage. And there's a rather arbitrary aspect between the different units. And it takes some getting used to the different relations, and certainly complicates the arithmetic of the system, the fact that the units relations are rather ad hoc and hard to remember. The metric system, which uses units like the meter, gram, liter, meter for length, gram for weight, liter for volume, then organizes itself using a decimal system. So it's much more logical and systematic. So once you've defined a meter for length, which is about this big, then other units of length are either multiples of 10 from the meter or divisions of the meter into 10. So we always multiply by 10 or divide by 10. And then there are these various prefixes that go in front of the word to tell us how many multiples of 10 we're dividing by or multiplying by. So a millimeter is very small like this. A centimeter is something like this. A kilometer, well, that's 2/3 of a mile roughly. So this is French in origin. It has its origins in the French Revolution, when the French kicked out their aristocracy, chopped off the heads of the king and various others, and instituted this more democratic, logical system. It was actually one of Napoleon's first accomplishments, was to institute this metrical system. And the system is often referred to in terms of SI units. So it's a logical system. It's very well suited for science and engineering. And the fact that the powers of 10 play an important role means that it's well suited for the arithmetic of our number system. So undoubtedly, doing calculations with the metrical system is easier, perhaps much easier, than with the imperial system. And as I've said, it's almost universally adopted. So you might think that, from what I've said, I'm going to adopt the position that we're just going to work with the metrical system because it's far superior. In fact, I don't have such a strong position as that. I think that there are merits in both systems, in fact. And the metrical system is not, in my view, perfect at all. In fact, it's a little bit unfortunate which units have been chosen. They didn't do such a good job, in my opinion. When you look more carefully, you see that a lot of the units in the imperial system are actually more sensibly chosen than in the metrical system. Again, this is only my opinion, but we'll talk about that a little bit later. But because this is an international video series, I want to make it accessible to people all around the world. And so I'm going to be using both the metrical system and the imperial system for our examples. This is not bad, and teaches young people how to think about different systems, how to convert from one system to another, which is a very important skill. So we're going to be using some examples from the metric system and also some examples from the imperial system. All right, so let's start with a discussion of length and distance. So the first thing that we need to do is we need to have a ruler. A ruler is something that measures length for us. And a good initial question is, how do we make a ruler? Of course, these days you can go into a shop and buy them. But 1,000 years ago, you couldn't do that. If you wanted a ruler, you had to make one. And making a ruler is instructive and not at all that easy. The first step is that you need a straight edge. You need something that has a straight edge. A piece of wood, typically, that's been planed so that one, at least, edge is flat. Okay, how to do that is a technical question. I remind you that if you want something that's straight, one way of getting something that's straight is to take a piece of string and tighten it. That way you get a straight line. So suppose we've gotten a straight edge, and now we want to make markings on it which will serve us as a ruler. How are we going to do that? Well, we're going to choose a unit, and we're going to mark the straight edge at regular unit intervals. So let's do that to this straight edge here. And I'm going to use this piece of paper here, and I'm going to rather arbitrarily make a unit. So let's say that I'm going to say call that separation 1 unit. I'm not going to give it a name because it's not going to be important for us, but I'm going to use this to mark our ruler. So what I'm going to do is I'm going to make a mark there, say, and then I'm going to move this over until that's lined up again, so I can make another mark there. Now these are equally spaced. I'm going to move this over again, make another mark, and then another one, and then another one, and I guess I run out. Okay, so there we have a primitive ruler that has 1, 2, 3, 4, 5, 6 markings on it, and hopefully they're all equally spaced, or they're more or less equally spaced, depending on how accurate I was with my lines and how carefully I drew them and how carefully I lined them up. Alright, so of course that might not be a fine enough ruler. We might want to subdivide things, or we may want to start with a smaller unit. So we could start with a smaller unit, like suppose for example we wanted a unit that was that size. We could start with that and then repeat that. But that might not be as accurate as actually taking an existing ruler like this and subdividing each one of its pieces. So for example, if I take this thing here and I figure out where the halfway point is, I may have to make some construction to do that, then I can use this to make a halfway point on all my little segments, so they're all sort of looking the same. Okay, now I've got a finer ruler than I had before, one with more subdivisions. I can be a little bit more accurate with this ruler. And the more subdivisions I have, well, the more accurate I get. So that's good, and we've got a ruler now of this size, but maybe we want a bigger ruler, say one like this. Well, then we could repeat the same process for that. But what we could also do is we could use our existing ruler. So suppose that this ruler here is really a copy of that one. So I could use the existing ruler and then come down here and essentially copy this one several times to make a more consistent, longer ruler. And I'm just going to do that here. I'm going to use inches, which is in the imperial system. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've used the ruler once. Then I come over here, and I'm going to repeat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5. Okay, there's a ruler marked in imperial inches. So there is a ruler marked in imperial inches. And with a ruler like this or a ruler like this, then we are in a position to go out and measure things. So let's have a look at two rulers from the two main systems, the imperial system and the metric system. So I've already shown you essentially a imperial system ruler. This is a foot ruler. And I've essentially copied it here. So that's an imperial foot. And it's composed of 12 subunits called inches. So there are 12 inches in the foot. And here's roughly how an inch looks like. It's about the width of a thumb. 1 inch there, 12 inches to make a foot. There's also a larger unit called the yard. The yard is exactly 3 feet. So if I took one here, and then I put another one here, and then another one there, then I would get a yard. Maybe if I start here, maybe I'll see how that goes. There's 1, 2, 3. So just a little bit more than this, the width of this sheet here. Those are the 3 fundamental short measurements in the imperial system: the inch, the foot, and the yard. In the metrical system, the main unit is the meter, which is that long. And here is a meter ruler. There it is right there. All right, that's 1 meter long. It's a little bit longer than a yard. You can see it's about that much longer, about 3 inches longer than a yard. But they're pretty close, and both the yard and the meter are suited to outdoor measurement because they represent a man's pace. So if you take a reasonable size step, then you're getting pretty close to a yard or a meter. And so if you want to measure out a field or something, well, you just pace it out and you're getting the length of that field in meters. So it's a very natural unit for outdoor activity. Of course, for indoor activity, this is a rather long unit. But we can subdivide it. And in the metric system, we always subdivide by dividing by 10. Not by 12 or anything else, always by 10. So here we've subdivided the meter into 10 units. But I haven't marked them 1, 2, 3. I've marked them 10, 20, and 30. And that reason is because, for some historical reason, this unit, which is a decimeter, is almost never explicitly used. Rather, we think about 1/10 of it, which is called a centimeter. So a centimeter is about this big. It's about the size of a little finger. And there are 10 of them that fit inside a decimeter. And there are 100 of them that fit inside a meter. So most measurements, say in a house, in the metrical system will use centimeters, which are this big, or meters, which are this big. There's also a smaller unit called a millimeter. If we divide a centimeter by 10, we get a millimeter. All right, so we have these two systems here, and now perhaps it's appropriate for me to say that it's not at all clear that this metrical choice is superior. It's superior in terms of the powers of 10 involved. That clearly is more logical than dividing something by 12 or using a multiple of 3. So there's an arbitrariness here in the imperial system that we've divided the foot into 12 units and that we've chosen 3 feet to be equal to 1 yard. But the inch, the foot, and the yard are much better suited for length measurements for human beings. This is the reality. For many applications, these measurements are easier and more natural. They're just, the sizes of them are easier for us to work with. An inch is much more manageable than a centimeter. Not much of a difference. An inch is 2.5 centimeters, but it's a noticeable difference when you're measuring things. And again, here you can see the meter. Well, it's fine for outdoor activity. For indoor things, a meter is too long. A foot is a much more manageable unit. So, you know, if I had a magic wand and I could wave it, I would change the decimal system so that the fundamental meter was not this long, but was rather more like this long. And I would say that 1/10 of a meter, this kind of meter, would be given a name like an inch or a decimeter. But 1/10 of this unit is quite natural. So an inch and a foot are in fact quite natural. So that's not. So the case between imperial and metrical is not as cut and dried as the metrical proponents make it out to be. So we're going to measure in both systems in this course. So here are some exercises that you can do, or you can do with some young friends that you may have. And the first one is to actually make a ruler. To actually physically make a ruler. And this is an excellent project for young children. Get their hands doing some handiwork, making some markings, and then they have a ruler. And the rulers don't all have to be in the same units. Let the children choose the units that they want. And they have their own personal units, and they can go around measuring things with their own personal units. And that's what they should do. They should use the ruler to measure some of the things around them. The second exercise is to use either a metrical or imperial ruler to first estimate the lengths of various objects around your house, both inside and outside your house or where you live. And then try to make some measurements. See if you can figure out and compare your guesses with the actual measurements. So this kind of exercise where young people go out and actually make measurements is very important and an important part of becoming scientific. Thinking, well, there's guesses and then there's measurements, and they're not always the same thing. The measurements are usually more trustworthy. All right, so let's do a little bit of measuring just ourselves. So here are some examples of measurement. One natural thing to measure is my height. So to do that, I stand on the floor and I put my back against the wall and I get a book or something like this and I make a mark there, and then I get my ruler and I measure how far it is from the ground to the mark that I made. That's the height h. And my height happens to be somewhere between 5 feet 9 and 5 feet 10 inches. So I'm using a combination of feet and inches to measure height, and that's the traditional way of doing things. There's a notation that's commonly used. So the feet is often represented by a single prime and inches by a double prime. So 5 feet 9 inches is represented this way, 5 feet 10 inches represented this way. We don't have any fractions yet because we're just doing early K to 6 so far. So the best we can say is somewhere between 5'9" and 5'10" is my height. Of course, I could take that mark and then I could measure that same height in the metric system. So it would be more than a meter, but less than 2 meters. So somewhere between 1 meter and 2 meters is not very instructive. So we want to go to the finer scale of centimeters. And in centimeters, my height is roughly 177 centimeters. So 177 centimeters equivalent to somewhere between 5'9" and 5'10" in the imperial system. Let's measure something else. So my book, I've written a book, and at some point when you get to high school you can read my book on trigonometry. And there is roughly the dimensions of my book. So let's measure how much that is. First of all, with an imperial ruler. So here we have 0, 1, 2, 3, 4, 5, 6, 7 inches. And in this direction, 0 up to about 10 inches. We're just going to round to the nearest value. So 7 inches in that direction, 10 inches high. And that rectangle then is a 10-inch by 7-inch rectangle. In the metrical system, well, I can flip this thing over. There's a metrical scale here. So in centimeters, I can read 0, and you won't be able to read, but it goes up to around 18 there. And here, 0 all the way to around 25, a little bit more. So this is a 25 centimeters by 18 centimeters in the metrical system. This is the short form for centimeters, cm. The double prime is the short form for inches. Let's do one more example and measure the dimensions of this sheet. So let's start with the imperial system. Here's my foot, and I'm going to measure this. Okay, I'll mark there. That's 1 foot, and there's another foot. And it's more than a foot. It's about 11 inches, say. So it looks like we said 2 feet and 11 inches in that direction. And in this direction, 0 lines up to 12. There's 1 foot there. And it's 11 and a half, let's say 2 feet. So 2 feet in that direction. And now in the metrical system, I take my metrical ruler. Here it is. And we go from here to here, and it's showing, okay, 850, 860, 870, 880. It's about 88 centimeters. Remember, 100 centimeters is all the way, and this is 88 centimeters. And in this direction, about 600 millimeters or 60 centimeters in that direction. So in the imperial system, we would say it's 2 feet by 2 feet 11 inches. And in the metrical system, it's 60 centimeters by 88 centimeters. And when we're measuring things, we have to get used to actually specifying the units, so including the centimeters or including the markings for feet and inches. That's an important part of the measurement, is to identify which units we are using. Alright, so that's good. We've talked about length. Obviously, the next thing to talk about is weight. All right? So next time we're going to have a look at weight, measuring weight, both in the metrical and in the imperial system. I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.